So you want to learn to take a derivative, huh? Yeah, anyways, here's what a derivative is. You've got a function. Your teacher's given this to you, and they want you to mess around with it, okay? You need to know things about this function. One of the things you might want to know is what the rate of change of this particular function is. So, if I look at a point on this function, say right here, the rate of change is the slope of the function at that point. Here it's going down, it's negative. This right here is a derivative of the same function. So if I look at this point where it's going down, it's going to have a negative derivative, okay? This point right here is the function going up or going down? Neither. Good job. It's not going up or going down. This is a zero rate of change. And that's going to correspond to the point on this graph right here where it crosses the x-axis, aka the y value is 0. So the derivative, got it? Okay. Over here, the rate of change is positive. It's going up. So I'm going to have a positive derivative. Now, I'm sure you're wondering, how do I take one of those? Well, don't worry. This guy right here knows the answer to that.
Do you erase for me? So there are a lot of different strategies to taking derivatives, and you're going to have to know all of them, unfortunately. And unfortunately for you, there's kind of a lot, but that's okay. So the first and easiest rule for taking a derivative is the power rule. So what does the power rule mean? If I have a function, we'll just start with the example before I give you the rule. If I have a function f of x equals 2x cubed plus x squared plus 4. Using the power rule, taking the derivative of this function, I'm going to get 6x squared plus 2x, and that's it. How did I do that? Well, here's our formula. So, given a function x to the n, the derivative of this function, d to the dx, of f of x is equal to n times x to the n minus 1.
So
Okay.
basically, you take this number and you move it in front of your variable. And then you take your exponent, which previously was n, 3 up here, and you make it 1 less. So it became 2. Fantastic.
Absolutely fantastic. So if you have a constant 4, well, what's right next to this constant 4? There is an x to the 0. So when I take the power rule of x to the 0, I get 4 times 0, x to the negative 1. What is 0 times anything? 0. So that's the basics of the power rule. Ugh. The next rule is called the product rule. Now, this rule is not just product rule is applicable when you have two different kinds of functions. Let's say I have like e to the x or sine of the x. The rules of taking the derivative of this function is different than just x. So if I have f of x is equal to let's say x squared natural log of x?
No way.
No way. How do I take the derivative of this? I can't just use the power rule. And what's the derivative of natural log of x? Well, that's something that you're going to have to memorize. This is just one of the rules that we have as a derivative. This has its own rule, and this has its own rule. And these are derivative identities that you'll memorize. Now, when coming for the derivative of this function, I can't just take their derivatives at the same time. So what I do is I take the derivative of the first one, using the power rule, I multiply the 2 over, subtract 1 from 2, I get 2x, I multiply it by the natural log of x. After that, I take the derivative of this, which is 1 over x, and I multiply it by x squared. And this leaves me with 2x natural log of x plus x. So the rule we're using here is if we have a function f of x equals g of x times h of x, then the derivative of this function is equal to the derivative of g of x times h of x plus g of x times the derivative of h of x. And that's the product rule. The next rule is the quotient rule. This one's a little bit more complicated. So I'm going to start with the definition and then I'll show you an example. Quotient rule. Given a function f of x equals g of x over h of x, the first thing that we need to make sure is that h of x does not equal 0, because then the function would be undefined. Now, this formula is a little gross, but the derivative of f of x using the quotient rule is you take the bottom function, you multiply it by the derivative of the top function, minus the top function multiplied by the derivative of the bottom function. And we put that all over the bottom function squared.
Good job.
So this is a rough formula. You're definitely gonna have to practice this a little bit. But if I have an example here, we'll use an easier function. Let's say f of x equals x over x plus 1. I'm going to write the answer up here. The derivative of f of x is equal to the derivative of the top function multiplied by the bottom function. So the derivative of x, using the power rule, is just 1, multiplied by the bottom function, which is x plus 1, minus the top function, which is x, multiplied by the derivative of the bottom function, which is just 1, all over the bottom function squared, which leaves us with x plus 1 minus x over x plus 1 squared, and then we get 1 over x plus 1 squared. The last rule is the most fun, and that's the chain rule.
Oh yeah, the chain rule!
You want to talk about the chain rule, Daniel?
Are you getting bored of talking about the derivative rules? I'll talk about the chain rule.
Talk about the chain rule.
Okay, so suppose you've got a really long, complicated, annoying function that has a bunch of different things inside of it. Give me an example.
Cosine of x squared. It's a very simple example, I guess.
Okay, suppose we've got cosine of x squared. We'll call this boy f of x. I freaking love f of x. This is annoying because cosine's a function and x squared's a function too, and this one is inside the other one. And I guarantee they're not married. So that's disgusting. What I'm finna gonna do is cope with the inside first, and I put it on the outside, and then basically, here's what you do. You take the derivative of the whole thing, just the outside function, kind of ignoring what's in the middle to start. Okay, so x squared, we don't care what's inside the cosine function. We're just gonna take the derivative of the outside function. So step one, outside function gets derived with consent. Okay, after you've derived the outside function with its consent, in this case, the derivative of cosine of x is sine of x. Then, this is f prime of x, by the way. You have to derive the inside function, also with consent. Okay. The derivative of the inside function, we use the power rule, which Andrew told you about earlier. They get multiplied together. That's it. That's all you need. So maybe we should do one more example just to make sure you've got that one down. Give me the, don't even worry, I've got one. F of x equals, I hate trig functions, so we're not going to touch them.
Oh, good one. Good one.
Outside function is something cubed. That's easy. We make that something 3 squared. Okay? Power rule for everything in. Inside function, also easy. We just power rule each one of these. So I have to put that there. This is a mathematical symbol that means take what's here and put it there. This power rule to x, this power rule to, what happens when I mess with a constant? You go to prison. But in this case, taking the derivative of this constant with consent would give me 0. Do we care about 0? No, we don't. So this is 2x plus 2. I have to multiply it by this. So this whole thing becomes 3 times 2x plus 2 with x squared plus 2x plus 4. And I'm now realizing that you're not a math major and I haven't taught this in a while, and that is probably inadequate, but many other people on the internet have endeavored to teach this before. So if you were not thoroughly entertained by our attempt to do this, then I would recommend
reading your textbook or going to class.
Going to class. That's what I'd recommend. Highly, the best thing to do to cope with, I don't know what you just did, is go to class. Your professor gets paid to teach you this. We don't. Bryce is here.
Bryce is here.
Have this
Have this.
forever. Do you want this gone?
Oh my
It's fine.
Doesn't it smell
And that's
so
all
good in
zeros.
here?
god. That smells so good. How did you know that that's what I was saying? Oh my gosh, dude.
Ah, I
It
just
smells
knew.
so good in here. Holy
Oh.
cow, what is that, dude?
Bring
That is what we're having for dinner.
What? But what is the name? What is the?
Chicken shawarma. My favorite jeans are coming out.
Why coming out?
My favorite jeans are coming out, not I'm coming out.
That outfit says it otherwise.
Yeah.
No, I
Oh,
did.
this is fire.
Daniel, I just recorded a video of us teaching somebody how to do a derivative.
The derivative.